Alrighty, so in this video, we're going to talk about an arc length and a sector area. And I just want to remind you that when your theta is measured in radians, the arc length is directly related to theta. You just take theta, multiply it by the radius length to find the arc length. So that's our formula that we're using. And let's go ahead and take a look at some examples. Okay, so here we are. Assume the orbit of Mercury around the Sun is a perfect circle. Mercury is approximately 36 million miles from the Sun. Question A. In one Earth day, Mercury completes 0.0114 of its total revolution. How many miles does it travel in one day? Use your answer from part A to determine the radian measure for Mercury movement in one Earth's day. Okay, so we have a sun and the Mercury is going around the circle, in the circular motion around the sun. Okay, so it says in one day it completes 0.0114 of its total revolution. So what's the circumference? What's the full distance around its orbit? Well, we have the circumference formula, 2 pi r. Okay, so we have 2 pi, and r is our radius is 36 million miles. So 36 million miles. Okay, so let's go ahead and put it into the calculator. We have 2 pi times 36 million miles. We have 72 pi. This is the exact number, but if you want to approximate, if you want an approximation, there is a button here on this calculator, right here, F to D and D to F. So you just press the button and it gives you a decimal approximation. All right, so it is about 226.19 million miles. But that's the full circle around, right? So we're told that Mercury completes only 0.0114 of its total revolution. So as we learned in how to figure out portions, 0.0114 of the whole, so times the full thing. Okay, so what is it going to be? So this number times what do we have? 0.0114, right? Okay, so I got about 2.58 million miles. Okay, so that's our answer to question A. Now let's talk about question B. Question B says, use your answer from part A to determine the radian measure. So what did we just find? We just found this one distance. This is the arc that traveled by Mercury, but by one Earth's day. So this little thing is 2.58 million miles. Now, they want us to find the arc. Well, we know the formula, right? S equals R times theta. So we need to find theta. We know S now is 2.58 million miles, and we also know R is 36 million miles. Okay, so let's put it into our equation. 2.58 million miles equals 36 million miles times our angle theta. So if we want to find angle theta, we have to divide both sides by 36 million miles. Okay, so million miles and million miles go away, right? Here they cancel out too. And what do we have? We have 2.58 divided by 36. Let's see. 2.58 divided by 36. That gives us 0.07 radians about. So 0.07 radians. That's the angle of theta. Okay, when I first looked at this problem, my train of thought was a little different. I was thinking, okay, we can find out this right away. Like, if the first full revolution around the sun is 2 pi, that's the angle, then the 0.0114 of this revolution would be, let's see, 2 times pi divided by 0.0114. What? Oops, silly me. We need to multiply. So 2 pi times 0.0014, we get the same value, 0.0716, what we had before. So I would actually approach it this way. And that just shows you that there are different ways to find what you need in math. So just, yeah. Don't get if you solve the problem in a different way that somebody else, more power to you. All right, so this is it for this problem, and I want you to try this one by yourself. Find an arc length along the circle of radius 10 units subtended by an angle of 215 degrees. All right, so go ahead and find it. So one thing that you need here is to convert your degrees into radians, actually, in order to use the formula. Don't forget about that. And we are moving forward to our next slide. And this is our formula for the section area, for the sector area. So in order to find the area, it's not the length along the circumference anymore. It's the area cut out by that angle. The formula is A equals 1/2 theta times r squared. Okay, so please remember this formula and let's apply it. It says An automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sprinkle of the sector of the grass of the sprinkler waters? Okay, so we have 30 degrees angle and we have 20 feet radius. Okay, so the formula is A equals 1/2 theta r squared. So what do we have? For r, we have 20 feet, right? So we put it in. So what about theta? Well, remember that our theta has to be in radians. So we have to convert 30 degrees into radians first. So 30 over 1 times 2 pi over 360, or just 1 pi over 180. Let's do 1 pi over 180. Actually, so that we don't have to simplify later. Okay, so degrees go away. Degrees cancel degrees. And also actually 30 goes into 180 6 times. So we have 6. All in all, when canceled, we have pi over 6. So for our theta, that's our angle. So for our theta, we're going to actually put in pi over 6. So let's calculate it. A equals 1/2 for theta, pi over 6. For r, 20 feet, we're going to square it. Okay. Multiplying across, we have pi over 12, 2 times 6. And then when we square 20 feet, we get actually 400 feet squared over 1, right? So we have a fraction. We need a fraction. Now, let's try and simplify this. And 4 goes into both 12 and 400. So when we cancel out 4, from 12, we left with 3, and from 400, we left with 100. So our last, our final is pi times 100. So 100 pi over 3 square feet. Now, if we wanted a decimal approximation, again, this is an exact answer, right? This is exact answer, but if we want a decimal approximation, we're gonna put it into a calculator. 100 times pi divided by 3, that's 104.7, about 104.7. So whenever your square feet, whenever you're doing a decimal instead of pi, that's going to be an approximation always, because as a reminder, pi is infinite decimal. So, and you cannot write an accurate infinite decimal ever. All right, so that's an approximation. Now I want you to try this problem by yourself. It says, in a central pivot irrigation, a large irrigation pipe on wheels rotates around a center point. A farmer has a central pivot system with a radius of 400 meters. If water restrictions only allow her to water 150,000 square meters a day, What angle should she set the system to cover? Um, Write the answer in radian measure to 2 decimal places. So they tell you how to round it as well. Okay, so go ahead and set it up. I suggest you draw a picture first, label everything, and go from there. And this is it for this subsection, and we're moving on to the next one.